Can you guys hear me? So today we'll be
Yes,
working
Karthik.
on. Yeah, thanks. Thank you, sir. So, guys, good afternoon, good morning, and good evening. Thank you for joining the session. Today, again, this is going to be a practical session today, where we'll be covering how do we look at SSH, and also we'll be looking at how do we work at firewall as well, right? And we'll be focusing on uncomplicated firewall or UFW firewall in Ubuntu. We'll also see what is the firewall types and what are the default configuration that we see in that part and other things related to that. Uh, let's take a deep dive into the part first. Right? Before we could go further, before I could start, what do you mean by SSH and things and all? Let's try to understand what is a shell, right? What do you mean by shell out there? So in a simple way, in any Linux operating system or anything that is available out the Windows or any operating system, there'll be something as shell. But before that, let's say there is your processor, right? In your motherboard, in Intel or AMD, then you will have your hard drive, right? Then also you'll have something called as the RAM. Right? This is called as a memory, and this is stored as a storage, right? These are all hardware devices. And let's say you got some application which wants to give some task to these devices, right? It could be browsing the net or watching movies or working on your Word document or anything. So this has to be the end level, the code has to be executed on the processor level itself. And how do we go about that, right? So usually for that, what is something is going to be called as a kernel, and this is what makes any operating system make. Right? What are the other things that we see? It's all additional attachment to this part. So kernel is the one, it will tell the processor what to execute and where to execute from, right? It will load it into the RAM memory and then it will ask you to push storage. That is what it is going to do out there, right? But the problem with kernel is it cannot understand your app language. The app language, whatever you're writing, this is going to be done in a very specific way, right? What we call as a machine code. This machine code cannot be understood by everyone, right? Any application also will not do, and they're not worried about that, right? So for that, whenever let's say a simple command like ls command or pwd command or whatever you do, that cannot be directly understood by the kernel. There's something in the middle called as a shell. Shell, you're directly interacting with the shell via the terminal. Understand that. So terminal is not shell. Terminal is just a tool to send command to the signal to the shell out there, right? So meaning when I type ls terminal takes this and give it to the shell, and shell checks what whether it is valid command or not. Only if it is a valid command, it will send it to the kernel. Kernel will translate to machine and then it will get the output and the process comes back in a similar way. Right? If the command is not valid, it does not go to the kernel, it directly come back to the message in the terminal telling that this is the. So meaning in a shell is a way to communicate with kernel. This is what is going to be there. So whenever you open your terminal in your system and you're entering command, that is nothing but that is going to be there. Anything, whatever it could be, maybe running a browser or anything, it is actually, it will go through the shell and directly is going to connect to that part, right? Only your device drivers and things like that, probably it will not go through shell. It will directly connect to the kernel, right? USB driver, not USB, other things. File Explorer is a different thing, but drivers are different. So they probably directly connect to the kernel, but most of the things will have to go through shell itself. Let the code actually get executed. So when you're executing on your own machine, it is called as a shell. Okay. So let's say I want to execute command on remote mission. This remote mission may be in your home network. It may be in another part of the world itself entirely. It does not make a difference, right? As long as you should be able to execute command for that part. So ability to execute command on a remote machine is called remote shell, right? So I'm connecting to the shell of another machine and giving it a command to execute. And this is what is basically is about, right? So this, where do you see this happening? Where do you need this option? Right? First of all, it is needed everywhere, especially in the cloud itself, right? Because you don't know where your cloud server is located. You just know its name, DNS name, or you know its IP address, and you want to execute the command, right? Most of the times, administrators never directly connect to the server that is present. Okay, so this is going to be very, very difficult for them to do that. And nowadays, there's in the utilization of VMs and things and all, it makes for that. So yeah, what I need the IP address for this location, and I should be able to do that. And each and every system in the world, right? It may be a router, it may be a firewall, it may be a switch, it may be a server, maybe your desktop, a lot of places. Everything can be connected via remote shell. Remote shell is a concept. Right? Remote shell is a concept. So what are the tools available for remote shell? The oldest one we know is called as a telnet, right? Not to be used anymore. The replacement for that is SSH. Okay. The problem with telnet is not secure. Problem with telnet is not secure because it sends everything in plain text. If I can capture the traffic between the client and server going via telnet, I can look at the password, I can look at the data and everything, right? So that is how it is going to work, right? Understand one thing, remote shell is only for sending commands, not data transfer. We will see other technologies that are there in SSH which can be used for data transfer, but there is the underlying protocol is different, same security feature is same, but the actions are different, right? You can never do file transfer via SSH as a protocol. It does not. Indirectly, you can always do, right? That is possible, but directly it is not going to be. It is going to be of much use. So remote shell, there are different types of tools that are available out there. Okay, there are something, there's a web-based approach I can do. Web-based approach also I can connect, right? PHP will support it, or any programming language. Python also will support it. Again, there are multiple ways, there are 100 ways of connecting to a system and executing a command out there. But why is that? One of the most commonly used is SSH. Okay, and why is this? Why is it recommended to use SSH? So SSH is nothing, the full form is nothing but secure shell. Right? It is exact copy of telnet. There is no much difference between telnet and SSH. Only difference is, right? It is going to tell telnet is not secure because it sends in plain text. Secure shell or SSH is secure because it encrypts the communication, right? It uses the public key encryption algorithm. That is the main thing about secure shell. If you are going to work on cloud or any infrastructure, DevSecOps or anything, without knowing SSH, you can't even think about it, right? It is a no-go, right? You cannot do anything in SSH without that part. For instance, in my organization, right? So where I work, we currently are working on 3 projects. And for 3 of these projects, for all the supporting components or anything, we have about 30 or 40 servers that are there. right? And all the servers will manage it from a single terminal, right? So all the servers that are remotely located, they may be on-prem or AWS or anything. All servers are managed by a single system via SSH, right? We'll see how do we connect to that and how do we, what are the things that we can do about it in a short span of time, right? But without SSH, it is not going to be possible at all, right? So secure shell, let's dig deeper into this, secure shell, right? So it's a protocol for secure remote logging. It encrypts communication over insecure network, right? So usually what used to happen is that when I'm communicating from my server, let's say my server is there in US and I want to give it some commands, I want to execute some commands out there. It was difficult to do it in a secure way because anyone listening between me and the server can do that. So here it encrypts the communication. In fact, your SSH is nothing but a VPN. It's a virtual private network is establishing there between the source and the destination. But only difference is this VPN is connection is between only the shell, right? It provides authentication, confidentiality, and integrity, right? No one can see your data, no one cannot modify your data, right? And it will help you authenticate in a secure way, right? And default port number is 22 for that. Okay, default port number is 22. Secure file transfer and SFTP are two different. So as I told, if you remember, SSH can only be used for sending commands, right? We cannot do file transfer in it. But there are SCP and SFTP are two protocols that are based on SSH, right? They are based on SSH. Here, when you do, you cannot do commands. You can only do file transfer, but the underlying encryption infrastructure, whatever the programs are there, it is used by SFTP and SCP for data transfer. Okay, this is, and we'll not talk about SCP and SFTP today. Maybe in the next class or future, we'll talk about it. Okay, so this is the main thing about SSH because it gives a secure communication, right? And it is also helps you with automation and all. It makes it much more easier. A lot of automation tools support SSH for remote communication, remote sending commands and everything, and all those things out there, right? For instance, think about, let's say you're running a CI/CD pipeline, right? You're running a Jenkins in your server right now, and this server has to deploy an application out here. What does do? Jenkins server will generate a establish SSH session, connect to the remote machine out here, and it will deploy. There are many different ways of going about it, right? It may not be SSH, it could be something else, but SSH is one of those easier way to do about it, right? I can do a lot of automation work on it, right? So in SSH, we'll have to think about authentication. By default, there will be two types of authentication: password-based authentication and public key-based authentication. All right, it is more secure, and we will be looking at how do we get this. Password-based authentication is supported by default, but we'll see what is the public key-based authentication, and we'll see how do you set up for that part, right? So when you do public key-based authentication, there will be no password required. So before we could understand public key concept of that, let's try to install SSH in an Ubuntu. Let's try to look at things which are important for us, right? Before we go into that component. So here, for sake of example, we'll be running the services on 3 different servers, right? I'll be running the SSH on Ubuntu, and this will be our main server, meaning other 2 devices will try to connect. Okay, And one of the devices, other two devices is going to be Kali Linux, right? And one more thing is going to be Rocky Linux, right? These are the most commonly used Linuxes that are there, but sake of example of them, right? You can also connect via your Windows as well if you want to practice, but it's not going to be. For here, it is a bit more easier for me to demonstrate. Okay, so let's see. So you could see here in my virtual machine, I'm having three different servers. One is Rocky Linux and one more is Kali Linux out here. So let me log in here. Let me check whether SSH is installed. Yes, it is installed and running. Let's say you don't know how to install SSH in Ubuntu. It's going to be very easy. Let me remove it and then reinstall it. So do it. Okay. See, understand one thing. By default, in SSH, there are two components. Okay. There's something called as an SSH client and SSH server. Okay. SSH client is present in all systems. Okay. So meaning if I do wherever I will try to instate the connection, right? For instance, when you have a browser is nothing but an internet client, right? Why it's called internet client? Because I connect to the internet via my browser, right? I connect to the web application server via my browser. That will act as a client. Here, SSH client is going to be that kind of an action on that. So meaning, I'll show you what I mean from that. So let me not install it. Okay. If I check now system control status, SSH, it will say, okay. Let me do one thing. Anyway, let me show it from a different scenario. When I do IF config, and you can see I'll get the IP address for my Kali Linux server. It is 192.164.74.145. Okay. So here, right. So whenever I type here SSH, let me give the username on there Kali at 192.168.74.145, I think, right? So this process is the client part, right? Where this particular command is a client part where it is allowing me to connect to a remote server and execute command on that particular location. Okay. So here it is not going to allow because it is not running. Running. Made a mistake here. The IP address. Right? So now it is executing and it is logged in as asking password for that particular user, and I can execute the commands out there, right? So here it does not mean that this kind of an action is possible by almost any device that is available out there. You don't have to install SSH server for doing this. But let's say I want someone to connect to my Ubuntu server and execute that. For that, I will need the SSH server in place, right? So sudo apt install SSH will do that activity for you. It will download the install and services for that, right? So let me reboot once my server for the changes to take effect properly. Okay. So it will just take a 2 minutes time, not more than that. Let's say this is a server here, right? This is a server and this is an Ubuntu server, right? In my case, I've named it as Java Web, right? This is the server out there. And that's I'm sitting as a client in the Kali Linux. If I want to establish an SSL connection, what is needed by me? What are the things that is needed by me? Any answers, guys? First of all, I will need the IP address or domain name, right? So if domain name is there, it will be DNS conversion is going to happen and IP address is going to receive out. Second thing, the user is needed and user should be present on server as well. Third thing is user authentication is required. So meaning in general, it is going to be password. Okay. So if I want to connect to Ubuntu server, I need to know one user, whoever is there. So in this case, student is the username. I know that name, and the password I've given for that is pass itself, right? All in small, pass, PASS is the password of that. If I want to connect in my Kali Linux to my Ubuntu, what is the first thing I need? I need the IP address, right? Let's check it out. So IP address is what? 192.168.74.146. So we have the IP here 192.168.74.146. You have username also. In our case, it is student. And we also have the password. In our case, it is just pass. Right. So is these three enough to connect to that server via SSH? Let's check it out. So let me connect from Kali Linux out here. Let me clear the screen. Let me increase the font. First and foremost is the SSH command. right? Followed by the username at the end. What was the username? The student, right? So again, at the rate of symbol, okay, I want to log in the student at where, at which server. In our case, it is the IP address 192.168.74.146 is the IP address that is belonging to the remote server. We don't have to enter password now. Okay, let's see whether that will allow, that server is going to allow us or not. Press enter, and you can see here it is giving us a warning out here. It is telling that we don't recognize that device whom we are trying to connect to. Are you sure? Right? This is, you're going to get this when you're connecting for the first time. After that, you will not get this message. Okay, so you click on yes. Okay, and press enter. Now it is asking for the student user of the system. So I'm going to enter the password PSS and press enter. And you could see I've logged into that machine. So here, student at Java. And here is also student at Java, right? So I can do anything now from here, right? I can do a lot of other actions out here. This is how we're going to connect to any remote machine. As long as you have a user authentication enabled for that user, and there is some permission that you are allowed to connect, it is going to allow you to do that process, right? From a hacker perspective, compromising SSH is something I want to do, right? This is my main criteria, because I can have a complete access over the system. I can execute, I can comment and things like that, right? Compromising SSH is very important. Okay, ability to execute code is very important. A lot of big bug bounty programs where you get highest paid money is when you're able to execute the code. Okay, so you can see here, I can do anything out here. I can remote machine, I can connect mkdir. I'll create one directory out here, right? So ls, you can see one is here. And if you go back to my Ubuntu machine and check out, it is also created here, right? If you open the, here also could see that folder is created, right? And that is how it is going to work out. This is pretty much working on. Again, if you want to make any configuration changes here, you will have to make changes in the configuration of SSH. Where do you think SSH configuration files are going to be located? By default, all configuration files in Linux will be in etc folder. For SSH, it will be etc/ssh. This is the location where the configuration is there. If you remember, by default, it will run on port number 22. I can change it to port number, some other port number by changing the configuration file, right? This is the folder, guys, not the configuration file. This is the folder where the configuration is going to be there, right? The file is different. There are a lot of other things that can be configured as well in this. We'll see into that as well. So let me go to Ubuntu machine. Let me see the configuration file. cd/etc ssh. Enter. Let's see the folders and files, right? And these are all different configuration files that are there. And this is the one which we are supposed to change, conf_d_config. Okay. So I need to make sure you're logged in. Use sudo command. Without sudo command, you cannot make configuration changes to any of the configuration files. And sudo user is someone who's having an administrative privilege, right? Only he can run. A normal user will not be able to make configuration changes here. Go to Vim is an editor I'm using, SSHD. Let's go config, press enter. It's asking me for password, enter. Right? This is where the configuration can be done. And see here, I can change the port number here. For instance, let me change the port number to 2222. So by default now, if I want to connect from Kali Linux to SSH via here, I will not be able to connect via normally. Okay, I have to specify the port number of them. Before that, I have to give system control. Restart SSH. Not reflecting. Just a second. It's not updating. I don't want to restart it. Missing one step, crucial step here. Anyway, supposed to change the port number. Yes. So now it is telling port number 22 is refused because it is moved to port number 2222, if you remember. So if I want to connect, I just have to add one more option, -2, 2222 out here, and it will connect right now. See here, now it is asking, is going to choose out there. So these are some of the configuration changes which we can do. And one more important configuration changes, you have to make sure that is present there, right? It is there as it is. You should not change it. Is the root login permission out there. Okay. So here, if this option you could see here, permit root login, it is commented out. It means you cannot log in as a root user from a remote machine out here. That is very much crucial, important. If you don't enable this, it will allow you to log in as root. The thing about logging as root is very dangerous. It's allow you to do any kind of an action out there. There's no limitation. Sudo also has certain limitations. It cannot be done certain things beyond that part, but root is going to be given out there. You should not be doing that part. Always make sure this particular concept is given set things out there, right? Is permitted. And one more thing you can see, max authentication thrice and max session is 10. What does this mean? What does this mean? Max authentication price is basically telling at maximum number of attempts, right? It will allow for a thing. And max session is, let's say I'm logged in as right. This is one session. Okay. Like that, it will allow you to connect. I can also connect from Kali Linux here. right? I can also do, let me exit out of this. I can do SSH student student 192.68.74.146 -p 2222, right? I'm logging into the same user again here, but from a different machine, right? So we can make sure that only set number of sessions can be enabled out there. We cannot tell that, okay, anything more than this, it is not going to be allowed for that path. So that is also can be set up there. So there are different variations you will need to understand in your situation for this part. Okay, so now we have been working on this component till now. So let's assume as I told, I may be working on server number 1 and server number 50. You may be working on 50 servers or you may be working on 100 servers. Okay. Can you remember? Remember all password. Correct? Can you remember all password? No. Right? So what you are going to do? For all to 1 to 50 server or 1 to 100 servers, you will use same password. This is the technique what most of them will do. What is the problem with this purpose? If I can crack password in one server, all the 100 server is cracked. Right? Password is possible. If you're having password, there is a brute force attack is possible out there. I can crack it. Right? And if you're using a very weak password, it should not take much time out there. And this is a major issue. Right? In some cases, in the big data analytics, they'll be using thousands of servers, right? Hadoop, which is one of the biggest vendors in big data, they told their product can work on 25,000 instances at any time, meaning, and all the communication, there should be SSH users in all these 25. There should be some way of communicating with them. And you cannot have password 25,000 passwords and remember them. Right? So that is not going to happen on there. So we need to have some way of understanding how do we overcome this situation. Correct? We need to have some way of overcoming. How do we do this part? Right? So how do we overcome? We overcome using no password. You can't remember password. It will not use password at all. This is where cryptography is going to come into play. If you remember, in cryptography, there's something called as a public key encryption. In public key encryption, what is going to happen? There will be two keys. One is called a public key and one is called as a private key. This is what is going to happen now. So here, what we are going to do is, let's say this is the client. In our case, we'll call it as Kali Linux. And server is the Ubuntu server. Okay. So Kali Linux is going to generate one public key and it's going to generate one private key. And it is going to send the public key to the Ubuntu server, and there's one location where it will store that key. I will show you that folder out there where you're going to store. So when next time private key is not shared, only the public key is shared out there. Okay. So now when it wants to connect to the next time, it is going to send a request to allow to connection. Right. So what something is going to happen out there, what this is going to do is that it is going to take the public key for Kali Linux and it is going to use it to encrypt one, data. Okay, and it's going to send that encrypted data out here. Since I'm having a private key out there, I can decrypt that data and send actually what was the data that is sent out. So since it is able to decrypt it, only the user with the private key can decrypt that data. It can authenticate that the communication is coming from Kali Linux itself. So I'll be able to push into the data. This is going to allow for that part. Okay. Any questions, guys? I know it is very silent out here. Any questions till now? What you have done? So anyone not understanding what is happening out here, you let me know. I'll redo it out there. Not an issue. No issues. We'll finish up this. So now let me generate one. This is my Kali Linux is my client, right? If you remember. No, private key is not shared when the SSH communication is happening out here. Okay. See, it's what happens. First of all, probably I will explain what is public key encryption first before going in. See, in a traditional sense, something called as a symmetric key encryption. Let's say you take one file and you encrypt it. Okay, you take that file and encrypt it, and you're going to encrypt it using a password. Okay, so now then you can send it to the recipient person out here, and you will get the file which is in an encrypted format. He need to decrypt that file, right, for him to read the data. But for decrypting, what is needed? For decrypting, you will need the password. Okay, so now this password has to be sent, and how can we send it in a secure way? It is not going to be possible, right? So again, I have to encrypt that password in something else. Then how we are going to secure that data? That is going to be a big issue. Okay, this is going to be a bigger issue out there. Now this is the what we call is as the key distribution problem. Okay, how do we send this password to the destination in a secure way, right? Either these two people have to communicate with each other in some other place, exchange password, or if there's exchanging via email also, right? That is still not secure. Someone can read your email and things and all. It is again email again. Now the email services are encrypted. Before it was not there. Okay, so that is the major thing that is going to be there. So in order to overcome this situation, think about, see, this is not a solution that has been used, thought about when you're doing it in current situation after the internet has been there. It is being there for a bigger problem for that. If you have, this is a military problem, right? Two military bases has to communicate. They have to encrypt that message, right? So the enemy can read that message. So we have to, where do you get the password? So they used to have something called as a code books. Okay. So let me show you that. If you have seen some any machine, so this would be something like an one-time password. OTP was there well before in time, right? So anytime on this particular day, they are going to use a particular OTP. This was the book they used to have out there. Okay, this need to be exchanged in advance. Okay, and this bleeded into your regular IT department and networking as well, right? So to overcome this, there's an organization called NIST, National Institute of Standard and Technology. They anything that is standardized, they have to standardize it. It's an American institute. They are going to do TCP, UDP, firewall, whatever you see in comes under IT. Not only in IT, anything nuclear, it could be washing machine or anything. They have to standardize it. That's the. So they gave out it raised a tender where they need to come up with an algorithm where there are going to be the key distribution is going to be overcome. So for this, they came up with something called as a public key encryption, right? This is going to be there. Also, it is called as an asymmetric key encryption. If you are studying in your college or anything, this is what the name given to this. The logic is very simple out here. Previously, you remember we had only one password. Just a second. Normally, we had only one password. Now, what is going to happen is there are going to be two passwords. One is public key and one is private key. Meaning, when you run the algorithm, right? Algorithm is there. Something like RSA is one of the algorithms that are there. When you run this algorithm, it will generate two keys, right? It is a very large number key that is going to be present out there that we are going to look into that part. Okay. So here, let's say if there is a message, if I encrypt using public key, this can be decrypted using private key. Okay. And if I encrypt something with private key, right, this can be decrypted using the public key, meaning there is actually technically there is only key 1 and key 2. There is no public key and private key. The key which I make public, meaning which I share with everyone, is called public. The key which I do not share is private. Okay, that's the only difference. It is algorithm who is going to create two keys, and there we one is going to be shared with everyone, and one is going to be there. So for instance, if Karthik is there, I will generate one key, let's say KPU, one is public key, Karthik private key, right? So now if anyone, let's say John wants to send me a message, I would have shared this public key in my blog or website or anything. So he will take this public key, KPU, and he will encrypt that message. You'll get an encrypted message out there and he will send it to me. Now I can decrypt it. How? Because I am the only one who's going to have this number. So this is the processor. So this is your normal how your public key encryption works, but this can be used in reverse order as well. Okay, this can be used in reverse order as well, meaning how can we use public key for authentication, right? So remember KPV, the private keys, who is having it? Only Karthik is having this information. Right? KPU everyone is having. So what John wants to verify whether messages Karthik wants to connect to the John server and John wants to verify whether it is Karthik or someone else. So what is going to do? John is having a copy of KPU, right? Karthik public key. Is going to take a message. Let's say a message is hello, and he's going to encrypt it. What? Encrypt it with public key, right? Encrypt with KPU public key. Remember, KPU is usually what? Encryption, right? So I'll take this encrypted message and send it back. So now I'm able to decrypt this message. Okay. I can able to decrypt this message. I can send back the message telling that this is the message you sent. No one else is able to decrypt this message because no one will have access to this private key of them. Okay, this can also be done. It can be done other way also. What it will do is that it will send the hello world directly to KP Karthik. Karthik is having a private key. You will encrypt the message hello with KPV and send it back. Now it will decrypt using the public key KPU and you will get the message hello and I know okay. In both the cases, KPV is used to authenticate that decrypt that message or encrypt that message. Based on that process, I can tell this is what has happened out there. Okay, this is what a public key authentication usually will look like. So now in the SSH process, what is going to happen? Whenever here, what we are going to do, we are going to copy that process. So I will show you that part. So now let's say I'm inside Kali. First of all, what is required? The client which is connecting to the server will need a public key pair, right? Karthik wants to connect to John server, so Karthik will need a public key, private key, right? So how do you do that? You can generate SSH key in Linux, very simple. Let me come down to home directory, clear, SSH hyphen keygen. Okay, there are multiple things, it's just keygen is being used. Hyphen T RSA is the algorithm you're going to use. RSA is an encryption, public encryption algorithm I'm going to do. And hyphen B is the block size. So here, the block size is going to be given as 4096. It is the length of the key, right? The key size in encryption cryptography will always be 2 to the power of n. Okay, it will be 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, and so on and so forth. It will go. Right? Previously, we were using 512, then it is considered weak. Then we increase the key size to 1024. Then they told 2048 is ideal. Now 4096 is something is supposed to be good enough. So now let's come back and enter. So it is going to create and it is telling I'm going to store the key pair in this particular location, right? So .ssh is a hidden folder out there. It is going to put it out there. So let's see. I'm going to tell OK, right? And it is telling, do you want to enter any passphrase or anything? I'll tell no at the moment. I don't want, and this may not be ideal if you're connecting to multiple servers. Okay, automation is if you're manually connecting, you can use it, but if you're using automation, this may not be an ideal way of that. So, and you could see the key is generated. Okay, so if you go to /root, if you see here, this is the one I'm talking about, /root /.ssh. Right, this is the folder. I'm going to that folder. Right, if I give ls, could see there are two files out here, IDRSA and IDRSA.pop. For instance, what is there? Get ID_RSA. This is your private key, right? That is the private key which we generate. This is not going to be shared with anyone. Okay. The second one is IDRSA.pop. This is the one that is going to be shared with anyone out there. See, you can see IDRSA. It is telling what is the root at Kali Linux and things like that. So this particular content has to be put into the remote machines server out there. Okay. So for instance, I want to connect to the root user on Ubuntu machine. So what is the IP address here? Let me check. 146. So now there's one command here called SSH copy ID where student at 192.168.178, sorry, 74.146. Okay, now it will ask for password. Okay, port number is, we change, remember, 2222. By default, you don't, it will be in 22 only. Okay, you don't need to change. It is giving error. Okay, most probably I have to give here. Yeah, I'm supposed to give in the starting itself. So now I'll enter the password for student. Press enter. It is telling number of keys added 1 and things. This is not going to log into the remote server. It is just going to push the key, public key into the remote server of them. That's what it is going to do. So now let me come back to my Ubuntu machine. I'm in my current home directory, right? I'm the student user home directory. If I give ls, it will show all the files and folder. I have to show -e to show the hidden folder also. That is my SSH folder. Right, you can see there's an SSH folder. Let me go inside that .ssh and give ls. You could see there's one file out here called authorized keys. I'm going to give cat authorized keys. Press enter. You could see that my file out here, which was here, right? If you remember, this has been content has been copied to this particular location. If this is there, we can communicate with the server out here. Okay, so now if I do SSH student at 192.148.74.46, previously it asked me to enter password. Now, without entering password, it is able to do that. Right? As soon as I try to establish a connection, it will check is there any public key available for that device there. Then it will make modification for that, and then it will do. Right? For instance, let me come out of here. Let me delete this file. Okay, ls sudo rm keys. This file is deleted. Now, if I try to connect, it will ask me for password. Right? Previously, it did not ask. The reason is there was no file available out there. Okay, so let me try to push that file once again. So now, if you see, previously it was not there. Now, if that file will be there, cat, same thing is there. Now it will not be there. See, no password is required. It will be able to connect to that point and be able to work on that place of that. So this is how it is going to work. But there's one more thing you're supposed to do, right? And this is something you have to be very, very, very careful before doing it. The reason being is you have to disable password authentication at any cost. I'll tell you. So now What is happening if I give SSH? Right? It is asking me for password here because I have not pushed the code, right? So I have not done the public key for my Rocky Linux is not pushed to Ubuntu server. So it will not directly log in. It will ask me to enter password. So now let's say if you enable public key authentication and don't disable password authentication, the security is not there. Okay, you have to disable password authentication. Sudo vim sssd config. Sorry, I'm in the wrong folder. cd/etc ssh. This is the configuration location. Okay, this is not where your keys are stored. Sudo vim config. If you come down, right, it is showing as password authentication as yes. You have to do it no. Sudo system control. Right. So now if you enable this, if the configuration has taken effect, see here, it is telling previously it was asking for password. Now it is not allowing for that password change. Why? It is telling that password authentication is disabled. Only within the public key encryption, I can do this part. Okay. Only if I'm able, I cannot even push now. Okay. I cannot even do SSH copy ID because SSH copy ID will need the file to be password should be enabled out there because we enter password if you remember. So you usually initially what you're going to do before blocking it out, you push all the code, then you will remove the password injection out there. Okay. What is the problem? So one thing we need to make sure. So let's assume the Ubuntu server is in a very remote location. You don't have any access to that part apart from SSH. Okay. And you've disabled password authentication as well. So let's say Kali Linux is the only machine from which you are able to connect to the Ubuntu server. And for Kali machine, you have the public key authentication pushed out there. But by mistake, what you will do is you will generate RSA key one more time. You'll forget that key is there. You will generate that and you will override the existing key. Meaning you will generate a new key and you will not know about it. Right? So now the public key that is present here, okay, is different from the public key. Right? Is two different keys that are there. You can see, let's look at the last part, NVW and here JFW is right? Even if it is one change, it will not work. Everything has to match. Okay. So now if I try to do SSH, even though this will tell it is not going to allow because the key does not match that the hashing function which we used or the communication key exchange did not successful out there. Right? The key does not match any. So now the problem is how do you connect to this server? Anyway, here I have access to it. I can do this process out there. It's totally fine. But if this happens in a remote server, you're completely locked out, right? You will need someone physically go there and connect to that physical server and then work from there. This is a major issue. Okay, I'll just tell you, this has not occurred to me anytime. Okay, so once I was working on a remote machine, that was a Windows machine, we are doing some process. I had some issue. What I did was I went out. I wanted to restart the network, right? So how do you usually restart the network? You go to the network device, you disable the network, right? First thing is you switch it off. Then again, you're going to switch on the network. Okay, this is what we're going to do, right? After you switch off in a remote system, how can you switch on? Because your connection is terminated, right? Same thing happened. It did not go through its long term back. It's a stupid thing to do at the time. I disconnected it thinking like I was doing in my local machine, and the server went down. And this is where I was working for a very big company. They have thousands of servers out there. It literally took them 2 days to find where that server was, and someone had to go there and restart the server. That's it, right? It for this simple activity, it took 2 days. Think about if you're having a critical system where you're running a big server and you forget, you lock yourself out, you will not be able to do anything, right? Be careful when disabling password, right, in your system. Okay, but it is the right thing to do. You have to do it and you have to have that process. Should always key management, you have to understand. Whatever the public key and private key what we have used out there, there'll be security tokens and everything. If you cannot manage authentication, you cannot know how to keep your authentication key secure, you should not work as DevSecOps engineers or a system Linux engineer or anything, or cloud engineer, because anywhere you go now, you have to be used out there. Okay. So any questions, guys? Let me reset it. The IP address got changed, I think so. I restarted the network, remember? Same IP, but I restarted. So now it is asking for password. Okay. Yes. Fine. This is how it will work. So any questions, guys? So password authentication is very important. This is where we will be moving forward, right? Even if you want, right, you can use the same password key can be used for multiple servers as well, right? For instance, let's say here, let me check whether SSH is running, right? So both of them are having same IP. How's that? I mean the Ubuntu machine out there, that's why it is showing IP there. Okay, this is Rocky Linux. It is going to be SSHD, not SSH. Small variation in the command. So now, what is the IP here? 144. So now let's see. See the pipe, the default port number is 22 only there. It's not changed. So we are going to allow that. Right. The root login is allowed. That should not be done. That's a configuration issue and it's a vulnerability. Okay. While copying it, I had enabled installing for that, but it gave me a warning that it is insecure. But for testing purpose, I'm doing it. But in a production or real time, you should not do it. Okay. Now let's say, let me copy, right? 144. Here the username is root. And the default port number is 22. So if there's a default port number they're using, then you don't need to specify the port number specifically. I can do this as well. It is not going to affect. It's going to be the same as that. That SSH is going to put 22 by default. Okay, so now let me enter the password. Right, you can go here, check here, cd.sh ls cat authorized keys. Can see that is that. Now I can directly connect without entering the password. See here, it's connected directly. With a single public key authentication, public key, I can set up SSH connection to any device I want. Right? If I'm having 50 or 100 devices, all I have to do is I have to enter SSH root at 192.168.74 out there, and it will do that activity just fine. Okay. But the problem here you have to be very careful is whenever you're not using your terminal, you just have to lock your terminal, meaning you don't open your system and go. You have to lock your system and go, because if you don't do that, anyone will be able to just know the username and go through your history command and then connect to that and make any changes. So you have to be very careful that from that perspective onwards. But otherwise, this is how we are going to do. Right. And if you're writing an automation script, right? For instance, recently what I did was, this is a simple application I've written, right? It's an automation script where it will, I want to check out which are all the commands that are executed by in a particular. So what happened was, the situation was, we had given access to a developer to the server, and that particular developer, what he did was, he ran certain command which got the server down. Meaning server was not down, the application was down, right? So the client reached out saying that server, when they try to open, the application is not reachable. But we checked the server is running. But he did some mistake out there running the commands. But he told I did not run the command out there. Okay. So we got the history and things, but we did not get the timeline when it was there. So this is just a simple example what we created. And this is created completely using ChatGPT only. I have not written the code of myself. All I have to do is that I have to give some name here, right? For instance, let's say, what is the IP config? .144. Username is root. Port number is, password is 22. PSS. Okay. I can do this part out there. Or I can do is, I can set up, paste your private key out here. You can do that as well, right? So I am going to not do that part. So in this kind of a situation, right? So I can do is click on history. So it is some error is there. Okay. It was previously working for me. It's not working right now. Sorry, now you can see, right? Yes, that filtration process was not proper. See, these are all the commands that are executed in that particular server route. That could be there from my end. Okay, that is how it will work. So this is not an, completely, it is still work in progress. But if you have some kind of an application like this, where you connect to different servers out there that are there and connect and get information out of it, this is how it's going to work out, right? Where you can use that part, can connect to do that, can use the public key, because storing password here may not be secure, right? Using a public key encryption, entering your process is much better. Okay. So any questions, guys? Sir, I think probably the time is up. We can stop it here and we'll do the firewall next week. Event responding.
Yes, Karthik, it is absolutely fine. We can stop here.
Yes,
You have
guys.
taken almost like 1 hour.
Yes.
So
That's
you
what,
must take
because
rest.
no, but I can't complete that firewall today. If I
Yes,
start,
that is
that's
also
the
true.
problem.
That's
That
fine.
is the
We can
problem.
continue the next one.
Yes, we'll do that part next week. Guys, this has to be interactive. Only then, you'll be able to get more out of these sessions, right? So that would suggest it would be ideal. You can do that part. Okay.
So thank you, Karthik.
Thank you, sir.
Thank you, everyone who had the patience to be there for the 2 consecutive sessions. Thank you.